Here, we're starting with vector mechanics, focusing specifically on force and how it can be resolved. Think of motion as something that can be broken down into parts or built back up again, and vectors are the tools we use to understand this process. When we talk about the construction and deconstruction of motion, we're basically looking at how forces combine to create movement, or how a single force can be separated into components, making complex motions easier to analyze. This foundational concept will help us understand everything from simple pushes and pulls to more complicated systems involving multiple forces acting together. Let's dive into how this works step by step. Force happens whenever there is an interaction that causes a change in motion or shape of an object. We classify force as a vector quantity, which means it has both magnitude and direction. Its size or strength is called magnitude, and this is shown by the length of the arrow in the diagram. The direction indicates the orientation of the force, like the angle shown here as 30 degrees. The standard unit we use to measure force is the Newton, abbreviated as N. This combination of length and angle helps us fully describe any force acting on an object.
When multiple forces act on an object, we can combine them into a single force called the resultant force, which shows the overall effect of all those forces together. If the forces act in the same direction, we add their magnitudes to get the resultant force, making it stronger in that direction. On the other hand, if the forces act in opposite directions, we subtract the smaller magnitude from the larger one, and the resultant force points in the direction of the greater force. This way of combining forces helps us understand the net influence on an object's motion.
When adding vectors using the head-to-tail method, you place the tail of the second vector at the head of the first vector. This allows you to visually combine their effects. It's important to note that the order in which you join the vectors doesn't change the result. Once joined, the resultant vector is drawn as a straight line from the starting point of the first vector to the end point of the last vector, showing the overall combined effect. This method helps simplify complex vector additions by breaking them down into clear, manageable steps. Any single force can be broken down into smaller forces called components. These components are always positioned at right angles to each other, like the horizontal and vertical directions on a graph. When you add these components together, their combined effect is the same as the original force. This process helps us analyze forces more easily by looking at the influence in each direction separately before combining them back into the full force. When we look at this diagram, we see a force represented by the black arrow labeled F, which is acting at an angle theta. This force can be broken down into two components that are at right angles to each other. One along the horizontal axis, labeled Fx, and the other along the vertical axis, labeled Fy. These two components form a right triangle with the original force as the hypotenuse. The significance of this is that by resolving a force into these perpendicular components, we can analyze the effects of the force more easily in each direction. The length of each component corresponds to the magnitude of the force in that direction, and together they combine vectorially to recreate the original force. This breakdown is fundamental in mechanics because it simplifies how we understand and work with forces in multiple dimensions.